Hello students, welcome back to another video. In today's video we will do paper 6 of course code 0625 October November 2024 variant 2. So question number 1 is saying figure 1.1 represents a stack of glass microscopic slides. Here we have microscopic slides which are stacked over each other. A student takes measurement from a stack of glass microscope slide in order to estimate the number of slides in a stack. The slides of the stack have been covered with the tape so that the student cannot count the number of slides in a stack. Figure 1.2 shows side view. Here we have length, height and width. Using figure 1.2, measure the length and width and height of the covered stack of slides in centimeters to the nearest millimeter. So I have to measure length, width and height. I will bring my scale and put it over here. And if I take the reading, this reading is 7.5, so length is 7.5. For height, the reading is nearly 1.3, and for the width, the reading is 2.5. Now, B part says, the student uses a balance to measure the mass m of the covered stack of slides. Here we have a balance on which we have the stacks. Write down the mass m of the covered slides to nearest 0.1 gram. That means to 1 decimal place. So here we have 7. At 2 decimal place we need to drop it as it is greater than 5. So I'll increase the number before by 1. So it would be 57.9 grams. Question number 2 says calculate the density of the glass. Use your results from part A and part B and the equation that is shown. So here we have the equation. Give the units for your answer. So mass is 57.9, length is 7.5, width is 2.5 and height is 1.3. Doing all the calculations in the calculator, the density would be 5.3. Now to units, mass is given in grams. Centimeter times centimeter times centimeter would be centimeter cube. So units are gram per centimeter cube. C part says the teacher write down the mass and the thickness of single slide on the piece of card. So thickness of each slide is 0.11 centimeter and the mass of one slide is 4.2 grams. Use your answer in part B1 and the information in the card to estimate the number of microscopic slides N1 in the covered stack. The mass of the complete bundle was 57.9 and the mass of one slide is 4.2. To get the number of slides, I will divide 57.9 with 4.2 and answer will be 13.7. To round off the value, the slides would be 14. Part number 2 says use your answer of part A and the information from the card to obtain another estimate of number of microscopic slides in the covered stack. So we have given the height of all the stack slides, which is 1.3, and in 1.4 figure, this height of one slide is given, which is 0.11. To get the number of slides, I'll divide both values and I'll get 11.9, which is roughly equals to 12. D part says two quantities can be considered to be equal within the limits of experimental accuracy if the values are within 10% of each other. State whether your values N1 and N2 can be considered equal. Support your statement with calculation. So the question is saying that two values are supposed to be equal if the difference between them is 10%. So let us see what is the difference between N1 and N2. N1 is 14 and N2 is 12. To calculate percentage difference, we use this formula. Now let me substitute the values in this formula. The maximum value that we have is 14. So 14 minus 12 divided by 14 plus 12 divided by 2 and multiplying whole thing by 100. So the answer that we will get is 15%, and this difference is greater than 10%. So these values are not equal. So I will write the statement as 14 and 12 are not within the experimental accuracy and they are not equal. ePath says, suggest one reason why the estimated values of n are different. Why we are getting 14 one time and 12 one time? Because the slides might not be identical in mass and thickness. That's why we are getting different values. Now, question number 2. A student measures the resistance of light emitting diode when the current in it changes. The student set up this circuit that is mentioned. The student connects the voltmeter to measure the potential difference across 220 ohm resistor. Then he closes the switch. Then records the voltmeter reading PQ in the top row of table 2.1 and opens the circuit. On figure 2.1, draw a symbol for voltmeter connected to measure the potential difference across 220 ohms resistor. So this is 220 ohms resistor and I will connect voltmeter in parallel to it. The voltmeter reading is shown in this figure. Write down the reading in the top row of table 2.1 under the heading VPQ. So it's 2.4 and I have to write in the table 2.1. So I will write 2.4 over here. After doing so, the B part of the question is saying the student disconnects the voltmeter from P and Q, reconnects the voltmeter across the LED between the points Q and R and closes the switch, records the voltmeter reading QR in the top row of 2.1 and then opens the switch again. Calculate the current in the circuit in part A using this equation where the resistance which is provided is 220 ohms and we have to write the answer in table 2.1. So voltage PQ we have already written is 2.4 and the resistance is given by the question which is 220 ohms. So I will divide these two values and I will get the current. So current is 0.0109 amperes. So I will write it in table 2.1 over here, 0.0109. Now, CPath says calculate the resistance of LED using this equation and record your answer to the suitable number of significant figures for this experiment in the top row of table 2.1. To calculate the resistance of LED, the equation is already given. We have to put the voltage across QR that is provided by the question which is 2.1 and the current across the whole circuit is already calculated. So we will just put the values. It would be 2.1 over 0.0109 and the resistance across LED would be 192.67, but we have to write it in suitable number of significant figures, and when you see the table the values are written to three significant figures, so I will only write three significant figures, so answer would be 193. D part says the student removes the 220 ohm resistor from the circuit and replaces it by 330 ohm resistor. Reconnect the voltmeter across the resistor between P and Q and repeats A and C for 330 resistor. Now you can calculate the value of potential difference PQ across 330 ohm resistor and put the values in table 2.1. So we are going to repeat the same calculations again basically. So first of all we need the voltage PQ. So I can use Ohm's law for it, V equals to IR. So if I want the voltage across PQ, then it would be VPQ is equals to I, which is same everywhere because it's a series circuit, and RPQ. Now what will I do? I'll just substitute the values, current multiplied by the resistance PQ, and I will get the voltage as 2.5 volts. Now the table information is fully completed. E part says as the resistance between PQ changes, the current in the circuit changes. Use your result in table 2.1 to write the conclusions. State that how current changes affects the potential difference QR across LED and the resistance of LED. So let me just go back to the table that we have just completed. You can see in the table that current changes from 0.0109 to 0.0076. That means the current is decreased in value. When the current decreased, what happens to the voltage across LED or the voltage QR? The voltage is also decreased from 2.1 to 2. So the voltage of LED decreases, but what happens to the resistance of LED? The resistance of LED is increased from 193 to 263. So the changes are very clear that decrease in current causes the voltage of LED to decrease and the resistance of LED to increase. F part says another student uses a variable resistor to control the current. Draw the symbol for the variable resistor. So the symbol of variable resistors look like this. We have an arrow over the resistor sign. Second part says explain one advantage of using a variable resistor for this purpose rather than the procedure carried out in A and B. In A and B part, we disconnected the circuit and then plug in another resistor of 330 ohms and then take the readings again. So using a variable resistor will avoid the disconnecting of the circuit, and it will also give us the continuous set of values. Question number 3 says a student investigate the image formed by a converging lens. The apparatus is set up as shown. This is illuminating object, this is converging lens holder, and this is screen. And the student switch on the lamp, places the lens at distance 20 centimeter from the illuminated object, and adjust the position of the screen until a sharp image of illuminated object is formed on the screen. Measure on figure 3.1 the nearest 0.1 centimeter, the image distance d from the center of the lens to the screen. Now the distance that is already provided is this distance from the illuminated object to the lens, which is 20 centimeter, and we have to measure this distance from the lens to the screen, and this nearly appears to be 12.1 centimeter. Second part says figure 3.1 is drawn to a scale of 1/5 of full size. Calculate the actual image distance V from the lens and record your value in 3.1. The question is saying that the distance in paper is 5 times smaller than the distance in actual life. So if the distance on paper is 12.1, that means in real life it would be 5 times bigger than 12.1. So to get the actual distance, I'll multiply 12.1 with 5. So actual distance is 60.5. Now B part says the diagram in figure 3.1 shows the illuminated object and the image drawn full size when U is 20 centimeter. This is the object and this other triangle is the image. Show two ways in which the image differs from the object. The difference is very clear. The image is enlarged and the image is inverted. Second part says the magnification m of the image can be calculated by using this equation. Use your answer to calculate the magnification of the image. In this table, we have u and v both, u being the object distance and v being the image distance, and magnification has the equation v over u. So v is 60.5 and u is 20. And if we divide both values, the magnification would be 30.025. As every value is written to one decimal place, so I will round off my value to one decimal place and it would be 3.0. Writing the answer into the place provided. C part says the student repeats the procedure in A part 1 for the values which are given. The student's results are shown in table 3.1. Plot a graph of V on y-axis and U on x-axis and draw the best fit curve. So this is the information. I will plot it into this graph. X-axis are for U values and y-axis for V values, and I have plotted all the values in the table, and now I will draw the best fit curve, which is this. D part says use your graph to find the values of V when U is 30 centimeter. Show clearly on graph how you obtain the necessary information. So when U is 30 centimeter, you can clearly see the y-axis or V is 31 centimeter. So I am writing 31 over here. E says the focal length of the lens can be calculated by this equation. Use the value of u and v from D part to calculate the focal length of the lens. U is 30 and v is 31. So I am plugging in the values of u and v. 30 times 31 is 931 and 30 plus 31 is 61. Dividing both values, the focal length would be 15.2 centimeter. F part of the question says, state one technique used when doing the experiment to ensure the image of the screen is as clear focused as possible. To make the image clear, you can make the room as darker as possible, use bright illuminating object and move screen slowly towards the lens. Here we have question number 4. I will not read it out and I will just tell you by doing it step by step. Basically, we have same volume of hot water in every beaker and each beaker has different surface area or you can say different diameter, and we will check the effect of diameter of beaker on cooling rate of liquid. Firstly, the question says if we need any other apparatus than this. So we need a stopwatch and a thermometer and a ruler to measure the diameter of every beaker. After this, the question asks for the complete description of the method that we apply. So firstly, we will measure the diameter of each beaker that we have. After it, we will measure the initial temperature of hot water that we are using with thermometer. After this point, we will measure the time taken to reach a particular temperature by each beaker. And to avoid any errors, we will repeat the experiment multiple times. After this, the question asks for the key variables that you can control. So we can control the volume of the water that we pour initially and the initial temperature of the water that we pour into the beaker. Then the question asks for a result table to record your measurements. So we will draw this table. On one side we will write the diameter and on the next side we will write the time taken by each beaker to cool down to reach a particular temperature that we set. Then the question says how you will process your results to reach a conclusion. So to reach a conclusion, I will plot a graph between the diameter and the time and I will check how these two values are relating with each other. Thanks for watching the video. If it was helpful, please hit the like button and subscribe my channel.